Okay, so yeah, thank you. Sedaro, we deliver mission simulation at scale for the space and defense market. And what we're disrupting is really the previous generation of simulation tools in this market that can't handle the integrated, distributed, and automated nature of the future systems that will define advantage in modern warfare. So our product is an enterprise software platform that can simulate hundreds or thousands of complex vehicles across all the related physics and do that faster than real time and in an agile framework. The underlying core technology is parallel distributed simulation tech that at runtime, when you submit a job to be simulated, it actually generates the multi-physics simulation engines and optimizes them to load balance across cloud infrastructure. So this fundamentally different approach and that differentiated tech allows us to deliver simulations that are 100x scale and deliver them 10 times faster than is possible with alternative solutions in the market. So this simulation playback in the Sedaro platform, and hopefully it kicks off here, covers a submarine-launched ballistic missile threat from the Arctic targeting New York City. So a salvo of SLBMs targeting New York City. And the flight time, see if I can get that playing, the flight time is 15 minutes. So in 15 minutes, an integrated network of systems across all domains, air, sea, land, space, automated processes, manual processes, all have to work together to close that kill web and intercept those 10 SLBMs. If any of those individual nodes in the kill web fail to do their job, there are obviously disastrous and substantial consequences. And those things can happen. So what simulation does is it allows us to find those gaps, find the gaps that we need to close and address those risks, and optimize and decide and automate and train AI eventually to cover as much of this as possible. But a lot of people can provide a view like that, and you've probably seen them before. What makes Sedaro different? And the answer is scale. So with our platform, every node in that kill web can be simulated at full fidelity, all the subsystems, the components, and the associated physics. And U.S. advantage, general advantage superiority in warfighting today is primarily driven by information superiority. What we can do with this capability, more holistic warfighting virtualization, is drive agility, drive effectiveness, and also connect solutions from the market directly to warfighter needs. And that has the potential to really disrupt aerospace and defense broadly and ensure continued superiority and deterrence of conflict through U.S. superiority in decision making and innovation. And we're doing that, we're proving that today. We've flown tactical edge AI for the U.S. Space Force. Earlier this year, we're flying it again twice in the next year. We're delivering an LLM integrated tactical decision support platform that virtualizes warfighting across domains and then provides that LLM interface across the enterprise to help operators make decisions. And we're delivering a hybrid space architecture digital twin that will be used for AI training and AI-driven mission planning. So team, myself and my two co-founders, Dan and Bass, we came here from startups, from contractors, from government labs, and where we built space hardware, simulated space vehicles, and built deep tech software. And now we have a team of about 35 with really an ideal and incredible mix of top-tier talent in physics and sim software, and on the growth side, connecting that to government missions.
Aaron, sorry.
Yep.
Robbie, thank you so much. 4 minutes is up. We're going to turn it over to the judges. He's all yours.
All right, great. Thank you.
Talk about your business plan here. Is this software as a service? Are you going to operate it? You're going to you're going to sell it to partners? What's the plan? Maybe it's on your last slide there to really get it out the door.
No, this is good. It's a good place to land. So we've been at it 6 years. We had a lot of SBR support early on, and started selling a product about a year and a half in, and then have transitioned to, away from SBRs over the valley of death as of like 3 years ago. And the business model is software as a service, so annual recurring licensing of the platform, but unlimited headcount. Because a lot of the value in a digital capability like this is the connectivity to users. And then associated with the platform licensing, we provide implementation services. So we have those forward deployed engineers that are typically working on site with us that we have the facility clearance, TSSCI, we have the contract vehicle, $20 million IDIQ, and we can implement the platform. So basically functions like a cloud OS because we can build an app on top of whatever that differentiated SIM capability to be a wargaming tool or be the operational decision support tool or the AI training tool like the examples that I mentioned. So it's implementation services, commercial, as a vendor, if possible, as a direct cost on the government contract, pre-priced packages, and then the platform licensing.
Can you speak a little bit about the buildup of your models and the validation? I think you mentioned sort of you're differentiating, being able to have different levels and detailed models at kind of various levels there. Can you talk about that validation process and sort of the way you're approaching that?
Yeah, absolutely. So the simulation libraries are actually not formally licensed as part of the platform, which gives us a lot of flexibility in export and transitioning that large-scale sim tech to pure commercial markets in the future. But in the libraries, as you suggested, are physics engines that we've developed internally, and we build them in the framework that was developed alongside the core tech. It's really a full stack solution. There's that sim service, there's a configuration managed, modern software-based system for managing all the modeling content and the sim content. And when we build those component physics-based simulators, we build unit tests, and we have a modern, a DevOps pipeline and DevSecOps pipeline to make sure that all our ATOs are maintained and documented automatically, and that also, more to your point, that the physics meet certain basic requirements. Though, especially when you get to the scale of integrated simulation that we're talking about, and the value is that it's agile and it's adaptable, so you change what you're asking the platform, you change your system design. The sim's different now. It's going to perform differently. The quantitative metrics for traditional VV&A are going to change. But the advantage is also we're cloud native, so not only can we run the 1,000 core sim, but we can run it 1,000 times and build as part of the pipeline for a particular application the uncertainty analysis and things like that quantitatively into the solution. So we meet basic stuff, and then we wait for a customer to tell us, the sim, the output of this overall workflow needs to be accurate to this level, and then we can monitor it, and if it fails that, then we can charge implementation to improve a simulator or fold in a third party. The architecture naturally lends itself to any existing capability to be put in the loop and co-simulated in the cluster or remotely, which is essential in this market because everybody has a tool. They trust the tools are important.
Thank you.
Do you have any commercial business case that you're looking to pursue?
So today the focus is defense and intel, where we found success, where we've been able to scale the business and be a profitable 35-person business with only 2.6 million dilutive capital in. Now, over the life of the company, like the first 5 years really, we were doing dual use and more creating the platform for that, creating the associated business model for that, and then all that testing really led us to focus in on where we can scale and make the biggest impact today, which is the DoD and IC market. That said, the underlying tech has been set aside from a data rights perspective as pure commercial. When we do a SIBR, when we implement with a customer and they keep some data rights, that's just content to the platform. And so we don't have to be sensitive about it, and we'll retain that, cloud scalable distributed sim tech into a commercial market in the future, or whoever owns it at that point. So,
how are you thinking about security? So this seems to me like this could potentially be a very ripe soft spot for bad actors to kind of come in the back door, especially if you're on the cloud. So
Yeah.
how are you investing in security?
Absolutely, and you can't be important in this market without you want that to be the case almost. But security has been a big part of our process and business, for the 4 years that we've been selling the product through OTAs and more formal programs. We've got accredited instances. We're supporting mission ops for an SDA, 2 constellations in secret level mission ops. We can deploy on-prem, Google Cloud, AWS, Azure. We've deployed in ATO environments or sandboxes for all of those. And our CTO knows more than he would like to about IT and cybersecurity now. We've also just hired and we've made investments in a team that's built this into our pipeline. So all the docs, all the scans are auto-generated through the pipeline to the max extent possible. And we can clear an ATO now, at least the examples we have, IL5, 6, in 2 weeks, 2 FTE weeks. Not in real time, in our FTE time, maybe 6 months to a year in government dependencies. But
Awesome, thank you.
How deep do you go into the physics-based simulation? Because the example you showed has orbitology
Yeah.
and missile tracks, but are you getting to the sensors, the spacecraft themselves? How deep do you go?
yeah, we do. The libraries that we have built in today, like that we deliver with the platform for free, have an extremely high fidelity space vehicle simulation. That's a lot of where I came from, and it's better than anything else we've seen, certainly commercially available, and we can deliver it fast. So it's telemetry level, it's voltages, currents, integrated power, network, ACS, reaction wheel speed, fuel level. We have robotic manipulator libraries, docking ports. We can dock and couple the physics for integrated systems. A lot of fidelity on the space side, and then increasing fidelity for missiles and aircraft and other systems. But a lot of it's applicable. You do SATCOM, you can put the same physics on the ground and the same logic and networks and stuff like that.
Robbie, thank you so much.